Quick sort is very efficient way of the sorting, and we can use this mechanism to many complex problem to solve it, right? So the main paradigm for the quick sort is the divide and conquer. Means if this data set has been given, you have to divide the data set into two subsets, and again further you divide this data set in two subsets, and you have to do till all the data is sorted. So this is the way we implement in the quick sort. So take an example. If this is the number given, how you will divide? So that technique is important here. That is called the partition. Means on which number you have to partition, that is important. So for that you pick up any element. So if I can pick up the 9, suppose. So the number you are going to pick up, that is called the pivot element. So you take any number and keep that number in their sorting position. Sorting position means, so suppose if you pick up the 9, so keep the 9 in such a way, in such position, so all the element before 9 must be smaller or the equal, and after 9 it must be the greater. That means this 9 is their sorting position, right? But this number could be anything. That should be sorted, should not be sorted. This number should be sorted or should not be sorted. I am only having the concern for this 9. So 9 should be there in the sorted position. So if you take the example for this one, so suppose in this example, if you pivot considering the 9, so you keep the 9 here, and before the 9, what is the element of the element? 8 and 2. And after 9, what is the greater number after 9? So it will be the 15, 14, and also the 16, 10. So if you see here, before the 9, this is a small number, and after 9, this is the greater number. So I can say that in the given number, one element got sorted, and that come there in the position, their own position. So earlier if you see, 9 was the 0 at index 0, now it came in the index 2. And this position is called our dividation position. From here we will divide and make the two sub-array to further sort it. So in this case, if you see here, if your 9 is coming here, if your 9 is pivot element, then this side will come 8 and 2, and this side will come 15, 14, 16 and the 10. And for the every time when you divide, each time when you are dividing your data set, at least one number must be sorted. So if I can say this is the first partition, one my number got sorted. Now here this is the second dividations, so must be one number is the sorted here, right? The same way one number is sorted here, and this is the way we can continue here, right? So thing is that you every time you take one number and put that number in their original position, in their sorted position, and again do the same operation here, right? So what we will do, we will put our logic here on the bigger side, and that logic recursively we do the recursion and apply to the all the sub-element. So the main important thing in quicksort, how you will keep this pivot element at their original position, at their sorted position, and that is called the partitioning in the quicksort. So now let me explain you what logic should be there to keep this number in the sorted position, the pivot element, right? So for that, what you have to do, you can take any element to be considered as a pivot, but for the simplicity I am always taking the first element is the pivot element. So int pivot is equal to 9 here, and that is your left side and that is your right side. Means I will use the 2 pointer, one will go from this side, one will come from this side. Okay, now start from here. So I will say this is my I and this is my j. Okay, so your pivot element is nothing that equal to data at the left side. Your left is the 0, right? So in the pivot is the 9 came. Keep I moving till you get the greater compared to your pivot element. So keep your pointer increment until unless you will get the element more than 9. So this while loop will be continue if you get it equal to the pivot or less than the pivot. Where you have to stop it, where you will get more than the pivot. So in this case, if you see 8, first it is step for 9. 9 obvious compared to the 9, it is equal. I will not take anything, move it here. Now I is here. 8 is smaller than the 9. So equal is smaller, don't consider, move further. Now came here, yes, this element is greater than 9. You stop the I here. You stop the I, now start the j. So here I is going to increment, right? Now reduce the j till you get the smaller than the pivot. This 10 is greater than pivot, don't consider. Take the j here. So I do the j minus minus came here. So now in this position if you see I is here, j is here, right? So if I is less than j, obvious I is at the 2, j is the 5, I is less than j, we can swap. We can swap the element between 2 and the 15. So your new array become the 9, 8, 2, 14, 16, then 15, then the 10. So 2 came at the 15 position and the 15 came in the 2 position, right? Index would be changed for the 2 and 15. So index is here. So our I was there, our I was at the index of 2. So here is your I and j was on the 5. Here is the j. Again keep moving till you get the greater number. Yes, I came here, 40 is greater than 9, still my pivot is the 9. So move here, now your I came here and the stop. Why stop? Because it got the greater than the pivot. Do again here, j, 15 is smaller than 9, no. 16 is smaller than 9, no. 14 is smaller than 9, no. 2 is smaller than 9, yes. So j will come here and now is here j. But now if you see, I become greater than j. So we will come out the loop. Means now this is the position we got the pivot position, and the moment I is crossing to j, means j is smaller than the I, means you got the position for the pivot, and this time you have to swap pivot and the j. And now if you do that, your number become 2 will become here 8, 9, and this will be the as it is. So now if you see here, your pivot will came in the actual position. So before the pivot, everything is smaller than the pivot. After the pivot, everything is greater than the pivot. And one partition is complete. Now you can divide your problem into the 2 subset. This is the subset 1 and this is the subset 2. No need to consider the 9. because your 9 is already come into the original place. So if you see the index of the array is this one, right? So the subset is here. So if suppose this is your middle position, middle means from your divide. So next time when you recursion the problem, that will go 0 to middle minus 1. This is your one subset. Another subset, middle plus 1 to the 6. If this 0 is your start or the left, whatever you say, and this is your right. And you will do the same operation recursively, and once time you will get that you all the number got sorted. So this is the main funda how you will do the partitioning, right? It's very simple. Take one element as a pivot, keep the I and j, two pointer mechanism. So keep the I till once you get the greater than the pivot number, and reduce the j till you get the less than the pivot number. And if I and j has not crossed to each other, swap between I and j. So if you see here, I swap between I and j, but the moment I and j cross each other, then swapping happen between pivot and the j. So we do the two kind of swapping. One swapping between I and j when if I less than j. If I less than not j, then we will do this swapping and use this code in the recursive way, and your element will be the sorted. So if you see the complexity here, I will show the code in the laptop. If you see the complexity, on the best case or the average, you will have the n log n. When you get the equal partition, equal or more than the equal. So here the 3 element, here the 4 element, here the 6 element, here also the 6 element. But suppose if I give you unbalanced data, means data is already sorted. So in this case, what happen? Nothing would be get the left side, everything is the right side, right? In that case, in the worst case, your complexity become the n square. Let me show in code in the running laptop, then you will get the more idea of that, right? And you will see the different data set and how it works there. So let us start the sorting here. So what we do, right? Take one data set, and first we do the partitioning thing. That is the important thing, right? So take partition, and I will get the data here, and left side and the right side, right? So first and foremost, we have to consider as element as a pivot any element. So for simplicity, I am taking the pivot element is the left side element, right? And we have to run the two pointer. I start from the left side and j start from the right side, okay? And then we have to move I pointer till we get the greater than the pivot, right? So move I pointer will be moved till we get the less and equal compared to pivot, right? And then we will move it plus. When this will be stop, when I will get the greater number. And also we have to move till only when I is less than the j, not more than that, right? And the same way for this left pointer, now take the right pointer. So we have to move when your j pointer is greater than the pivot. Here no need to check the I and j, because it will maximum it will come to the left side, and we have to give the equal sign, so it will not any problem, and j minus minus, right? And check if we have to swap, right? Only one condition we have to swap, if I is less than 0, right? Means I and j have not crossed each other. So in that case only we have to swap which number, we have to pass the data and swapping between I and j, right? And we have to do this logic till when I does not cross the j does not cross to the I. Only till we have to do that. If j cross the I, then we have to come out from the while loop, and we have to swap between this time between pivot element. What is the pivot element position? Left. So between the left position and the j position, and we have to return the j, because j is the middle now. So we got middle position as the j, right? So this is the code. Now we have to write the code for the swapping, right? So it might be easy. So private void by passing the data, and it is just the swapping. So I data will go into the j, and j data will go to the I. Okay, and you will get this one. And now we have to do this process recursively, right? So for this recursively, you have to write the main method now, and we have to pass the same thing. The final, the first, the main data we are going to send, and we will send the start and the end, means the complete array, right? And we have to do this operation when your start is always when than the end, right? That means we are going to compute. We have to recursive till start does not cross the end, right? So what you have to do here, first you have to find out the middle number, right? On the board what I told you, that take the middle number, right? So how you will take the middle number? So we have to call the partition, we have to pass the data, and we have to pass the start and end. Now we got the middle. Now from here you have to make the two subset. One subset from start to middle minus 1, and second from the middle plus 1 to the end. So you call the same method, pass the data set, and this time from start to middle minus 1, and second partition data and middle plus 1 to the end, right? That's it. Now just you call this method from the main method. So you make anything, or you can do take the static also, anything, sort quick, and you call the sorting, pass the data, starting is this one and ending is the this one, right? Before that I will just print what was the data before sorting. So you can see this was the before sorting, and this element we can again print the same, because sorting is happening in the in place. That's why space complexity is the one. You are not going to take anything, right? And after here, and just run it. So if you can see here, this is got the sorted, right? So 2, 8, 9, 10, 15, 16, this number, right? So this is the sorted. If you take any duplicate number also, it should work. Let me take the 15 and check is working or not. So it should also work. So 15 should become the 2 times here. So this is how it works. Okay, thank you very much.